Good day, Uncle Taki. Today I'll be going through trigonometry for matric. So let us go through the method of solving the problem. We ID the problem, then we find the building blocks, followed by unpacking the solution, and step 4 is we cross-check the answer. So let us look at the first problem, which is 1 over 1 minus sine theta minus 1 over 1 plus sine theta is equal to 2 tan theta over cos theta. We will start with the left-hand side. We've noticed that there's a 1 minus sine theta and a 1 plus sine theta. If we remember our algebra and we look at the following algebraic equation, where we have a minus b, a plus b, where a would be 1 and b would be sine theta. When we evaluate that, we get a squared minus b squared, which is the difference of two squares. So our common denominator of those two fractions is 1 minus sine theta, 1 plus sine theta. So 1 over 1 sine theta goes into there, 1 plus sine theta, bracket, minus, that goes into there, 1 minus sine theta, close bracket. Okay, we unpack this, so it's 1 plus sine theta minus 1, minus times a minus is a plus, plus sine theta. Okay, if we look at the multiplying of this out, it's like it's a difference of two squares, so that's going to be 1 minus sine squared theta. The numerator, we have a plus 1 and a minus 1, so they go out. So we end up with 2 sine theta over 1 minus sine squared theta. If we come back to our building blocks, we have 1 minus sine squared theta, which is actually equal to cos squared theta. So here we will have cos squared theta. The top is 2 sine theta. Now we need to look at the right-hand side. So the right-hand side is, I'll just put RHS. That is 2 tan theta times 1 over cos theta. Then the tan is sine over cos, so that will be 2 sine theta over cos theta times 1 over cos theta. We can simplify this further, so that's 2 sine theta over cos squared theta. Therefore, the left-hand side equals the right-hand side. And we've actually gone through the 4 steps of identifying the problem, finding the building blocks, unpacking the solution, and cross-checking. This is another Funda Tanda moment. I'm going to show you how to do the 11 times table. So normally if we take a number like 2, 3, 5, and we multiply by 11, instead of multiplying directly by 11, we take 2, 3, 5 and multiply by 10 plus 1. So 235 times 10 will be 2350, and 1 times 235 will be 235, which you add up is a 5, an 8, a 5, and a 2. Alternatively, we can solve this problem. I actually showed it to my late Uncle Gregory, and he said to me, there is an easier way, and this is what he showed me. 2, 3, 5, and then you put a 2, a 3, and a 5. And if you add vertically, you get 5, you get 8, you get 5, and you get 2. And the answers are absolutely equal. Exponents. Now we're going to work with exponents. If we look through our basic building blocks, a to the m times a to the n is a to the m plus n. Then a to the m times a to the minus n is equal to a to the m minus n. And 1 over a to the m is a to the minus m. This is also an important rule. A to the m bracket to the power of n is a to the mn. And a over b to the m is a to the m b to the m. So let us look at an exponential equation, which is a type of equation you get in matric. So we have here 5 to the power of 3x plus 2 equals 1. When you're doing an exponential equation, you need to have the same bases on both sides. What we have to remember is that 1 is also equal to 5 to the naught. That's very important, because any number, if you take any number to the power of naught, is equal to 1. So we will change this to be 5 to the 3x plus 2 is equal to 5 to the naught. We have the same bases. Then we can take the exponents and we can put 3x plus 2 equals naught. 3x plus 2 will subtract 2 from both sides. So these two cancel, and we are left with 3x is equal to minus 2. So if we divide by 3 and divide there by 3, our answer is x is equal to minus 2 over 3. This is another Funda Tanda moment. Let us look at the 2 times table, which is very useful and used often. If we do the sequence of the 2 times, you get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now, if we look at these numbers, we will notice that after 5 numbers, you've got 2, 4, 6, 8, 10, we get again in the cycle a 2, a 4, a 6. So if we write it as 2, 4, 6, 8, 10, then we write the next one as 12, 14, 16, 18, 20. And then if we carry on, it will be 10 added to this will be 22, plus 10 more will be 24, 26, 28, 30. So you can see the even numbers of the 2 times table is a cycle of 5 numbers. And the same goes for the 4 times table and for the 8 times table. Continuing with exponents, let us look at some problems which include surds. A surd, if you take the square root of x, it can also be expressed as x to the power of a half. And in the matric papers, we do get problems using surds. So if we take the square root of 12 plus the square root of 27 divided by the square root of 75. We need to evaluate this problem. So the first thing we do is we find the factors of each number. So if we look here at the factors, we have 12 is equal to 4 times 3, which is 2 squared times 3. If we look at 27, 27 is 3 times 3 times 3, which is 3 squared times 3. And if we look at 75, 75 is 25 times 3, which is 5 squared times 3. So now we need to substitute these into the surds. So we'd have 2 squared times 3 plus 3 squared times 3 square rooted over 5 squared times 3 square rooted. So if you have a square root of 2 squared times 3, that's actually equal to 2 square root of 3. So this one becomes 2 square root of 3 plus 3 square root of 3 divided by 5 square root of 3. We take out root 3 as a common factor, and we have 2 plus 3. And then underneath here we take out root 3 and we will have 5. You can see now that the 3's can cancel, and we have 5 over 5, which is 1 divided by 1, which equals 1. And there's your answer. I'm going to give you a Funda Tanda moment, showing you how to add some simple fractions. So if we have to add 1/3 plus 1/4, we've been taught to find the common denominator, which is 3 times 4. So your common denominator is 12. Instead of solving it in the usual way, I'm going to show you how to solve it graphically. If we draw a grid of 12, that'll be like that. So it's a 3 by 4 grid. So in this 3 by 4 grid, I just need 3 of these. And then we have one more grid, which will be the answer. So 1/3 of 12 is 4. So because you have here 1/3 plus 1/3 plus 1/3, so it's going to be 4 blocks. And then if we take quarters, there's going to be 4 quarters. And there are 3 blocks for the 4 quarters. So if we add these, if we transfer these blocks, you have 4 from the third and 3 from the quarter. And here's your answer. You add all the blocks that have been marked out, which is 7 over 12. And that is the correct answer.